Hello, my name is Sanjana, and today I'm going to be talking about confirmation test of three types of gases, which are neutral gas, alkaline gas, and acidic gas. So let's start with neutral gas. So first we have O2 gas or oxygen gas. So the steps to confirm that the O2 gas is present is by placing a glowing wooden splinter into the test tube. And when the O2 gas is confirmed to be there, the glowing wooden splinter will be relighted. Okay, so here is how it should look like. This is into the test tube containing O2. The reason why you shouldn't put it near is because the glowing wooden splinter will relight when O2 is present. If you put it near the test tube, it will be relighted, but it will be relighted because there's O2 gas in the atmosphere and not because there's O2 gas in the test tube. So then the glowing wooden splinter will be relighted. So this is how it should look like. So next we have H2 gas. We have to place a lighted wooden splinter near the mouth of the test tube. And if the H2 gas is present, the lighted wooden splinter will be extinguished and a pop sound will be produced. So this is how it should look like near the mouth, and H2 gas will flow, the lighted wooden splinter will be extinguished, and you'll hear a pop sound, okay, when it's present now. So that won't happen if it's not present. Okay, so next we have alkaline gas, which is also there's only one alkaline gas that we learn in our syllabus, which is NH3 gas or ammonia gas. Okay, so the first step is by placing a moist red litmus paper near the mouth of the test tube. The reason why we're using red litmus paper is because we're trying to test the presence of something that's alkaline. And the reason why it has to be moist is because an alkaline substance will only show its alkaline property in the presence of water. So it has to be moist, or not, nothing would happen. And when NH3 gas is present, the moist red litmus paper turns blue. Okay, so next we have acidic gas. There's 5 acidic gases, so we'll go through this slowly. So the first acidic gas we learn is CO2 gas. So first we have to channel the gas produced through lime water, and when CO2 gas is present, the lime water will turn cloudy. So the reason why the lime water turns cloudy is because, okay, let's look at the equation. So you have CO2 gas here, which is what we want to test the presence of, and you have CaOH, in bracket 2. Okay, this is calcium hydroxide, and it's also known as lime water. So CO2 plus calcium hydroxide will produce calcium carbonate and also water. Calcium carbonate is a salt. It is also an insoluble salt. Okay, calcium carbonate is an insoluble salt. It's an insoluble salt that also has the color white. So what happens when you try to dissolve a small amount of white insoluble salt? It will turn the water cloudy because it does not dissolve. So it doesn't turn colorless, it turns cloudy because it does not dissolve. So that's why lime water turns cloudy when CO2 gas is present. Okay, so next we have SO2 gas or sulfur dioxide gas. There's actually 2 ways to test the presence of sulfur dioxide gas. Okay, the first way is by using acidified potassium manganate 7 solution. So we have to channel the gas produced through acidified potassium manganate 7 solution, and when SO2 gas is present, the purple acidified potassium manganate 7 will turn colorless. Okay, So the reason why that happens is because, okay, SO2 plus KMnO4 plus HCl. KMnO4 is the chemical formula for potassium manganate 7, and HCl is here because it's acidified potassium manganate 7, so it needs an acid to make it acidified, and it'll produce MnSO4, K2SO4, Cl2, and H2O. Actually, I'm not really sure about this equation because I searched this on Google and there's actually multiple answers. I don't know why. This equation kind of sus, but I don't know. So I'm just going to try to explain based on what I understand. Okay, so you have KMnO4, where this ion here, this permanganate ion here, it carries the color purple. That is why the solution here is purple. So the purple solution would turn colorless. So what makes it colorless in the solution? It's this MnSO4. Okay. Actually, everything else is also colorless, but this is the main reason why. Because you see, Mn here it's purple, but why is Mn here white or colorless? It's because MnSO4 is white. Yeah, it's white. Okay, it's a white salt because here you see this is a metal ion, and then you have a non-metal ion here. So when they react and they form a compound, it forms a salt. That's white salt. Okay, and it's not just a white salt, it's a white soluble salt. So what happens when you try to dissolve a white soluble salt in water? It turns colorless. So that is why the purple solution turns colorless when SO2 is present. Okay, so next there's another way to test the presence of SO2 gas, which is by channeling the gas produced through acidified potassium dichromate 6 solution. And when it is present, the orange acidified potassium dichromate 6 solution will turn green. So the reason why that happens is because, again, this equation, I'm not really sure of the equation, which is equation number 3 here. I found this on Google, so if there's any mistake, feel free to comment down below. Okay, so
the third equation, which is SO2 plus K2Cr2O7 plus H2SO4. K2Cr2O7 is the chemical formula for potassium dichromate 6. Okay, so, and again, like earlier, H2SO4 is present is because it's acidified potassium dichromate. This brings the acidified into the name. This is acid, so that's why it's acidified. Yeah. Okay, so these three reactants will react to produce K2SO4, Cr2, open bracket, SO4, close bracket 3, plus H2O. This is a white soluble salt, so it doesn't bring any color. It actually turns colorless when it's mixed in with water. So that means when I say the orange solution turns green, there's only one culprit here. This is green. Okay? This bad boy here is green. And as for the color orange, okay, let's look at this equation again. This doesn't bring any color. This doesn't bring any color. So again, the bad boy here is this. So this is orange and this is green. And why is that? Okay, let's look at. Okay, we all know potassium doesn't carry any color too. It's because it's white. So that means, again, the culprit here is this ion. The dichromate ion. Okay? Sorry. Yes, the dichromate ion. So, actually, it's because the dichromate ion. This element here has, I think it's called chromium. Yeah, I just checked. It is called chromium. Okay, so the chromium ion has the oxidation number of plus 6. Okay, so chromium ion has the oxidation number of plus 6. Its color is orange. So that is why this compound here has the color orange. And because ni ada potassium kat depan, this salt is a soluble salt. So that is why it forms an orange solution. And the reason why it turns green is because the oxidation number of chromium ion in this compound is plus 3. So when chromium ion has the oxidation number of plus 3, it is green. So an easy way to remember the color change in this in this for this test specific test is O to G, or in the word orange, you have an O and you have a G, you know, so OG, orange to green. And for this test, that turns from purple to colorless. Just remember PC, our personal computer, you know, my PC, your PC, yeah, purple to colorless, okay. So macam ni lah, just ingat. So this is 7, this is 6, okay. So PC aku OG, you know, my PC is original, my PC OG, okay. So next we have NO2 gas, which is actually the color of the gas is actually brown lah, okay. And since again this is an acidic gas, what you have to do is place a moist blue litmus paper near the mouth of the test tube. And the reason why we're using blue litmus paper is because we're testing the presence of an acidic gas. And by near, actually it's gonna look something like this. By saying near the mouth of the test tube, I mean something like this, okay. And since it's moist, it's not gonna be straight. It's gonna, like, you know, hang off to me a bit. So the reason why it's moist is because the acidic gas will only show its acidic property in the presence of water, okay. So below the moist, baru dia akan show that it's acidic by changing the color of the litmus paper from blue to red, okay. So that is it for NO2 gas. And next we have Cl2 gas. Litmus paper near the mouth of the test tube, which is the same as NO2 gas, but the result is slightly different. The moist blue litmus paper turns red, then bleached. So the explanation for why it turns red is the same as this, is because it's acidic gas and you only show its acidic property in the presence of water, so that's why we have moist blue litmus paper. And the reason why it turns bleached, okay, the reason why it turns bleached is because Cl2 is a bleaching agent. So that is why it bleaches the blue litmus paper. Okay, bleaches the blue litmus paper that has turned red, and then it just turned like white. Okay, yeah, this is white. Okay, so lastly we have HCl gas, or hydrogen chloride gas. So this one is also different. You have to bring a drop of concentrated NH3 solution near the mouth of the test tube, and then white fume will be produced. So why is white fume produced? Okay, so let's look at the equation again. Equation 4. So you have HCl is hydrogen chloride gas, and NH3, which is ammonia. When these two react together, it will produce this ammonia salt. Okay, and this salt here is white. And the reason why it doesn't form like a solid or anything is because usually when you're trying to test HCl, you won't just have HCl in a test tube. Usually you will be doing an experiment, okay, where there are two reactants in here, and this will be heated. Okay, those will be heated, and then you'll produce HCl gas. And then you bring your concentrated ammonia here, bring it near to the test tube and put it inside. Okay, and then because it's already heated, it'll produce, boom, it'll produce NH4Cl fumes, and not solid because it's being heated. Okay, so yeah, that's it for my explanation. Thank you. Goodbye.